Hey guys, wanted to talk a bit about Galileo and Newton and the first law of motion. So, real quick on Galileo here. He lived in the late 1500s to 1600s. And one thing that we've talked about already that he has said was that all objects fall at the same rate, regardless of how heavy they are. So, supposedly, he went up to the Leaning Tower of Pisa here and dropped off weights of different masses and showed that they hit the ground at the same time. So that was against what most people believed at the time. Most people thought heavier objects fell faster. Another thing that he said that went against convention was that only when friction is present is a force necessary to keep something moving. He eventually also proposed that the Earth was not the center of the universe, that the sun was the center of the universe, which he was sort of right. It's the center of the solar system. And he was called to trial eventually for this view, and he was put under house arrest. But let's focus right now on what he said about motion. So he thought about a ball rolling down a hill here, and if the slope is downwards, then the speed increases. And if the ball is rolling uphill, if the slope is upward, then the speed decreases. So what if it was rolling on a flat surface with no slope? Maybe the speed wouldn't increase or decrease. It would just be constant if the ball was really smooth and the track was really smooth. So does the speed change at all? Another thing that he actually tried was he let these different balls go from a ramp, and he noticed they would roll up to just about the same height on the other side of the ramp. But even if he changed the angle of the second ramp, like made it less steep, they went further up the ramp but got to basically the same height as before. So he thought to himself, this was just a thought experiment, what if it just was flat? Would it just roll on forever as it tried to get back to the same height? So he proposed that an object's nature is to not change its motion, not to be at rest, as people said before, but to not change its motion. In other words, he thought things did not want to accelerate. He came up with a term for this and he called it inertia, and it's still what we use today. The more mass an object has, by the way, the more inertia it has, the more it wants to not accelerate. Now, Galileo never really formalized it. So, same year Galileo dies, Isaac Newton is born, so late 1600s into the 1700s. And he took Galileo's inertia idea and he wrote the first law of motion, sometimes called Newton's first law of motion. So he said every object continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. You will have on the test a question that says state Newton's first law. You might know it better like this. An object at rest tends to stay at rest. An object in motion tends to stay in uniform motion unless acted upon by an outside unbalanced force. So what's that saying? That's a lot, but let's go through it. I think most of it's pretty intuitive. So, a body at rest, this kid says, tends to stay at rest. So, he's sitting still and the dog takes off running and he falls out of the back of the wagon here because his body was at rest and wanted to remain at rest. So, motion, in other words, tends to continue unchanged. So the other part, though, a body in motion tends to stay in motion. The car is moving, it wants to stay moving. So also motion tends to continue unchanged. So, but here's another important point. The motion is uniform, which means same speed and direction. In other words, in a straight line. So a moving car accelerates. Is its motion uniform? No, it's picking up speed. So it's not uniform motion. There must have been a force. A moving car decelerates, it hits the brakes. Is its motion uniform? No, it is changing its speed. So there must have been a force on that car. What about the moon? The moon moves at constant speed. Is its motion uniform? No, it is not going in a straight line. Therefore, there must have been a force on the moon. So maybe you can try this at home over the weekend and film it, the little tablecloth trick. If you pull the tablecloth out fast enough, because all the dinnerware wants to stay put because it has inertia, if you pull it fast, there'll be too little force and too little time to overcome it. So there'll be the inertia will keep it there. So to summarize, if the forces are balanced, then an object at rest will stay at rest. And an object in motion will stay in motion. They will not accelerate. Same speed, though, and direction. That's what it means about staying in motion. So to put it one more way, objects keep on doing what they're already doing if the forces are balanced. So what about if there's an unbalanced force? Well, let's first look at a balance case. Here's a physics book sitting on the table. There are forces on it. Gravity pulls down on the book, and the normal force, the table pushes up. But these forces balance. So it's as if there's no total force, and it remains at rest. An object at rest remains at rest. But if the forces are unbalanced, then there will be a change in motion. There will be acceleration. So let's say we skid the book across the floor. The normal force up from the table and gravity down, those still cancel, but there's also friction. There's nothing to cancel this force right now, so it will be an unbalanced force overall and change the motion of the book. So one more thing on this is the force also has to be an outside force. What does that mean? The force has to come from something other than the thing that we are trying to move. What? So think about it like this. Can you literally pull yourself up by your own bootstraps, like lift yourself into the air? No. You are the thing if you are the thing we're trying to move, then something other than you has to exert the force on you to lift yourself up. A few more quick things here, and then you'll be ready to do part of the problems here. Let's talk about mass and weight a little bit here. So mass, you'll probably learn in chemistry, is the quantity of matter in an object. But in physics, we also largely think about mass as a measurement of inertia. So mass is a measurement of how much things resist acceleration. In the metric system, or the SI system, mass is measured in kilograms, and that's abbreviated kg. Weight is not the same thing as mass. Weight is the force of gravity on an object. So the SI unit of force is measured in something we call a Newton, named after Isaac Newton. So just to give you an idea here, 1 Newton of force is about a quarter pound if you're used to thinking in pounds. 1 kilogram here on Earth weighs about 10 newtons, which is a little more than 2 pounds. Here's the equation, how we find weight from mass. If we have the mass, we multiply by the acceleration due to gravity. Remember, this is 10, and that's how we find the weight. So if we go back to this, 1 kilogram times 10 gives us a weight of 10 newtons. If we have the weight and we want the mass, then we would simply divide by g, divide by 10. And that's how we go from mass to weight and weight to mass. But one more important distinction between mass and weight is in space. Let's say you're in the middle of nowhere space, far away from the solar system. Does this anvil have any weight? No, there's no gravity to pull down on it. It wouldn't weigh anything. But does it have mass? Yeah, it's still got stuff in it. So it still has mass. So it still has inertia. So it still resists changes in motion. It's not easy to throw an anvil even in the middle of nowhere space. You can hold it up, because there's no such thing as up if there's no gravity. But it's not easy just to like flick away from you, because it still is going to resist acceleration. If you go to the moon, does your weight change? Yeah, it does, because the moon's got less gravity and pulls down on you with less force. If you go to the moon, does your mass change? No. How much stuff is in you is still the same, even on the moon. Let's say this, one more question. Which has more mass, a 1 Newton object on Earth, a 1 Newton object on the moon, or a 1 Newton object on Jupiter? Think about that. We'll answer that one when we see each other next. And you guys can go do some of the questions on unbalanced forces and weight and mass.